Let's draw our two triangles. Here is triangle ABC, and then we'll rotate it about point A so that C maps up here, and B will map over somewhere around here to B prime. Let's label these new intersections D, E, and F. We want to find the area of the overlapping region, so that's the area of A, D, E, F. We'll do that by first finding the area of triangle A, B prime, F, and then subtracting the smaller triangle D, B prime, F. The two base angles of this isosceles triangle are 75 degrees, including angle CAB on the left. This means we have 15 degrees remaining here. That's our angle of rotation. And since AB rotates to AB prime, we have another 15-degree angle over here. And angle C at the top of our triangle by the angle sum is 30 degrees. If we take a close look at triangle ADB at the bottom, again by angle sum, this angle D at the top is 90 degrees. So we'll put a right angle here and here. So now we'll do some angle chasing. The rotated triangle AB prime, C prime has the angles preserved. So this is also a base angle of 75 degrees. So angle DEB prime is again 15 degrees. That's up here, and then we have another vertical angle on the other side of E. That makes this angle up here, angle AFB prime. It's equal to the sum of 30 and 15 because it's an external angle of triangle CEF here to the right. So we have 45 degrees over here. Again, we preserve the distances after rotation, so the distance from A to B prime is the same as the distance from A to B, that's 20. And now we'll do the law of sines on triangle AB prime F to find the length of B prime F. This angle between the two 15 degrees is 60 degrees. So this ratio is B prime F over sine of 60 degrees. And that's the same as the ratio of AB prime over its opposite angle, sine of 45 degrees. So we'll solve for B prime F. Sine of 60 is root 3 over 2, and AB prime is 20. And sine of 45 is root 2 over 2. This simplifies to 10 root 6. We're going to use the sine formula to find the area of triangle AB prime F. So let's find the sine of angle AB prime F. That angle is 75 degrees, and we'll use the sum formula. 45 plus 30, root 2 over 2, root 3 over 2, and root 2 over 2 and a half. This adds up to root 6 plus root 2 over 4. Now we have two side lengths and the included angle, so we can find the area of this triangle. Our two sides are A, B prime, and B prime to F, times the sine of their included angle, A, B prime F. And we'll substitute. This is 20, this is 10 root 6, and then we have this sine. Multiplying this out and canceling, and we can factor out 50. We get 50 times 3 plus root 3. That's our first area. Now we need to find the area of that smaller triangle. We notice that this triangle EB prime D is similar to triangle ABD, so we'll use that to find the area of our smaller right triangle. From triangle ABD, we have that the cosine of 15 degrees is adjacent over hypotenuse, that's AD over AB, and solving for AD, that's 20 cosine 15 degrees. And similarly for sine of 15 degrees, that's BD over AB again, so BD is 20 sine 15 degrees. Without calculating the sine and cosine, we can go ahead and find the area of triangle ABD. This is 1/2 base times height. We'll take BD and AD. If we combine the factors and write it as 100 times 2 sine 15 cosine 15, you might recognize this as the double angle formula. So we can replace this with the sine of 30 degrees. That's 1/2, so our area of the bigger right triangle is 50. Since these two triangles are similar, let's find a pair of corresponding sides. We have triangle EDB prime that we're interested in is similar to triangle ABD. So the ratio of the areas is going to be the square of the corresponding side lengths. We'll pick B prime D, the shorter leg of the triangle, and BD, and that ratio is squared. Let's find B prime D. We'll do that by taking the distance from A to B prime and subtracting the distance from A to D. This was 20, and we have AD over here, 20 cosine 15 degrees, and we'll factor out the 20 and substitute it over here. In our denominator, BD is 20 sine 15 degrees, and this ratio is squared. The 20s are going to cancel, and we'll go ahead and FOIL out the numerator. and the denominator is sine squared. Let's calculate these three trig values, and then we'll substitute. We'll start with the cosine of 15 degrees using our difference formula. 45 minus 30, that's cosine cosine plus sine sine, and we'll substitute. Cosine is root 3 over 2, and sine is a half. This is root 6 plus root 2 over 4. Now we can square this to find our third term in the numerator. There's our squared cosine, and last is the squared sine. This is 1 minus the cosine squared. So we'll plug these in. Minus 2 times this, and then we'll add this, and this goes in the denominator. When we clear out the denominators of these fractions and combine like terms, this is what we get. And then we'll rationalize the denominator. So I'm multiplying everything in the numerator by 2 plus root 3. Our denominator is difference of squares. That's 4 minus 3 is 1, so we don't have a denominator anymore. So let's multiply all these terms here by 2, and then again, all these terms multiplied by root 3. And combining like terms. And recall this was the ratio of the areas. This is the triangle that we want, EDB prime. And this was the larger triangle underneath, ADB. We have this denominator here. That area is 50. To find the area of triangle EDB prime, we're going to take this expression and multiply by 50. Ultimately, we're going to subtract this from the area of triangle AB prime F, which also has 50 as a factor. So let's do that first. Again, we're finding the area of the overlapped region, ADEF, and we're taking AB prime F and subtracting the area of that smaller triangle. And we'll substitute. And instead of subtracting this, I'm going to add plus 50 and then take the negative of each of these terms. So this becomes plus 10 root 2, minus 8 root 3, etc. I'll factor out the 50 from both of these, and we still have 10 root 2. These two give us a minus 7 root 3, and then we have a 3 and a minus 15, so that's minus 12. If this is the form of the answer, then the problem asks for 1/2 of P minus Q plus R minus S. P is 50 times 10 and Q is 50 times minus 7. Taking a half of that, I'll just factor out the 25 for now. This leaves me with 10, and then minus Q is 7, and R is 6, and minus S is 12. And our answer is 875. If you'd like me to solve any other math contest problems, please leave them in the comments.